You're the worst airhead. Oh my gosh. At least you tucked in a shirt.
That's not. He's done it many days now.
He's learning.
He's getting better.
Slowly. Very, very slowly.
By the time we get to senior year, he'll actually address it.
Never know. All right, get out your homework. Homework, man, get out. Put your
I
mask
also
on.
lost that. You didn't do it. I have lost 15 things today.
You're gonna lose 10 points if you don't get out your homework.
I did it, but I can't find it.
Organization skills. Question on the homework. Here. Jace.
Number 20.
Number 20. Number 20. All right. Big, long words. In fact, they just want you to calculate the circumference of Saturn, Jupiter, which one? Jupiter? Okay. It says, if the circumference of Jupiter's equator goes around the center, is approximately 448,800 kilometers. So the circumference, C for circumference of Jupiter equals 448,800 or 800 kilometers, km. That's its circumference. About how much greater is the diameter of Jupiter to Earth? Now, what I left off was at the start, the instructions tell you something about Earth. So we need to compare, in this case, the diameters. So if this is the circumference, we got to find the diameter of Jupiter. So remember the formula is C is equal to pi times D. Well, it told us the circumference is 448,000. This is absolutely calculator territory right here. 48,800. So somebody grab your calculator. We want to solve for D. Therefore, what do we do, Jace? So somebody with a calculator, do that for me. And remember, this will be approximately because we're using 3.14. So the diameter of Jupiter is approximately, and this will be in kilometers. I'm waiting.
Oh,
I thought Jake's gonna do it.
yeah, I did too.
Well, do it.
So 142,857.47.
Point. Let's just round the nearest whole number. 142,857 point.
47.
Okay, so point 7. So what? 142,857 kilometers is its diameter. If we divide this number by 3. Okay. All right. Cool. And then what it said is that we need to, how much greater is Jupiter's compared to Earth? So we need to know Earth's diameter. In the bold, way above, it says the equator of Mars. Well, we don't Mars. We want Earth. It says the equator of Earth is approximately a circle with a radius of approximately 6,378 kilometers. 6,378 kilometers. So if that's the radius, its diameter would be. All right, double it. $12,756. What do we need to do with these two numbers now? And whatever that is the answer. And that's how it's done. So this one is not very challenging in the sense of what to do, but the number is absolutely, nobody wants to do that by hand. Okay, I would never put that on a non-calculator test. Absolutely, with a calculator, that's no. By the way, did somebody do that subtraction? Calculator.
130,101.
And the book says 130,000, so they did a bunch of rounding. So we got within 1,000 kilometers of the right answer. If the book has it right, I guarantee the book rounded as well too. All right, anyone else? All right, let's go over the answers. Hey, do not forget, I'm starting to see the same people. There must be a disease over here. I need to spray some disinfectant for homework. All right. I will never forget to put 0 in for your homework if you don't turn your homework in. Do your homework. That's your job. All right, 2 through 20 evens. Here we go. It says draw a diagram. Therefore, I need for questions 2 and 4, I need to, or sorry, 2 through 6, I need to look at your drawing. So we'll pick it up on number 8. Number 8 is 1,570 kilometers. Now they did some rounding, right? But they're claiming 1,570 kilometers. Yes? All right. Number 10, 40.8 meters. Number 12, they gave you a fraction. So instead of using 3.14, you should use 22 over 7, right? So question number 12 is 2 over 3. If you used a calculator last night, you might have 0.6666 repeating, right? Or 0.7 if you rounded. Number 14 is 110. Number 16 is 38.5. Number 18 is 770. We just did 20. The book answer is 130,000 kilometers. I mean, we just did it. We got 131,000. So that was good. Our answer is more accurate than theirs. Yes. 18 was 770. Okay.
14. I got 109.
What did I say the answer was? 100 what? That's fine. All right. Now, I know that on the list of supplies you're supposed to have is a protractor. If you have a protractor, absolutely use your protractor. If not, I have one for everyone. Please do not break one. These are $5 a piece. Don't throw them. Don't hit the next person, and please do not break these. If you use your own protractor, look up here. Fiskars, that metal one that probably your parents wanted to buy because it was nice and solid and they thought you wouldn't break it, right? Some of them from a couple of years ago didn't have a hole, right? If you have one of those metal protractors that doesn't have a hole, it's an unusable protractor, right? You got to have a hole in the middle so you put that on the vertex of your angle. So I usually just hand out protractors. So tonight for homework, listen up. There are no questions that require you to use a protractor. I generally, for 8th grade, I still give this class because I will have kids in 8th grade still don't know how to use the protractor. And occasionally, on a standardized test, there will be a requirement to use a protractor. So I usually use this class, and it's where it should go. I use this class as a last chance of getting you guys to know how to use it. Okay.
You put the thingy on the thingy. The wire of the thingy.
No, Jackson, you put this thingy on the thingy and then you figure out what the thingy is. Because then you
You guys are using the word thingy too many times.
I like that word.
All right, a lot of vocabulary today, a lot of drawing. Homework, let's see, quiz next Wednesday. We'll talk about it next week. There are 2 parts. There are 2 parts here. One says class exercises, one says written. These are quickly done. I mean, this is at most 10 minutes worth of homework. These are quickly done, but for many of you, this is all brand new stuff. You don't know what any of this stuff means. Yeah, we're going to spend some time with a protractor. You probably messed with that. But the rest of the stuff you may not have ever messed with. This geometry chapter jumps around crazily. We went from points, lines, planes to circles, and now we're on angles. It jumps around really quickly. It's supposed to be the last brush of polishing of your geometry knowledge. And then we have a chapter later on in the book that does surface area, and volume. I wish that those 2 chapters were right next to each other. It would go well together, but they don't do that. That's what we got to go over. I would absolutely not try your homework right now. I would take the class. You probably don't know if you're doing it right or wrong. Here we go. So today's class is just on angles. We're going to have another class on angles, and it's a bear. It's not this one. This is the easy class on angles. going back to the calendar, these 2 days, 6-5, A and B, it's absolutely make your head spin kind of stuff. Okay, lots of words, new words. You've never seen it before. 6-5 is a treat. 6-4 is easy. All right, angles. Okay, so what's the shape?
That's a ray.
What's the shape?
A ray.
If I turn my smartboard on and I move this ray,
What?
turn it back off. I don't need it again. If I put 2 rays together, guess what we make?
An angle.
So what's the definition of an angle?
Two
Rays
rays
together.
together.
2 rays that share a
Common
Wait a
star
minute.
point.
common, and we call it an endpoint. So that's actually the definition.
How did you do that?
Turn the smartboard on.
Do it. Do it.
Do it again?
Yes.
Well, then I gotta go back.
So it's not. No.
No, only works on certain ones.
You can do it. Smartboard, just push hard. You gotta touch it
Let's
though.
try.
Now push hard. Push hard. Now drag it.
Exactly. You're clicking it. You're clicking it.
No, turning the smartboard on.
No.
So what's the definition of an angle?
Two rays.
All right, write that down. Box 1A. Box 1A. It's a figure shape formed by 2 rays with a common endpoint. That's what an angle is. Now, most of you had last year. This is the same slide I showed you last year, and the same silly joke about a smartphone, if you remember from last year. All right.
Actually, but I don't remember you turning it on.
Well, that's the new thing I'm doing now. Okay. That way I can really mess with some people's heads. All right. We name an angle 4 different ways.
Oh.
4 different ways. The first way is we don't start at the middle. We start on one of the ends, right? Closer to the 2 arrows. And the rule is you got to stay on the black line. So we could call this angle ABC, or we could call it angle CBA, but you have to stay on a black line. Obviously, that is not a less than symbol. That is that's the angle symbol. Okay, so we can call this ABC or CBA. Actually, there's 2 other ways of naming an angle. Be careful, that last year you never saw this. If the angle is just right there, floating all by itself, we can also call this, Jaden.
I don't remember the full name. I remember when you got a number.
That's 4th one. If the angle is all here by itself, like there's no other angles around it, we can also call this angle, we can call it angle B, right? So a B is the common endpoint is called the vertex of the angle, and we can call this angle B. So this is technically the second way of naming an angle, even though the first way gives us 2 different ways. Okay. Now you're going to see this year a lot. Oh, let me describe when you can't do this, right? If I draw this shape right here, what did I just make? Okay, and obviously there's a point right here. Give me a letter. Okay, where is angle B?
In the middle.
Oh.
How many angles are there?
4.
There's actually more than 4, but there's lots of angles there. So guess why we can't call this angle right here angle B? Because I don't know if you're referring to that one, this one, this one, this one, this one, this one, right? There's lots of angles there. So when the angle is floating by itself, the only thing there is just this angle. Yeah, you can call this angle B. But when you have a more complicated, you will today, have a more complicated picture, you can never call it angle B. Does that make sense? It's just not descriptive enough. Yes. Yeah. Okay. Jaden also remembered, you're going to see this year, when it gets really complicated, the picture gets really messy. Sometimes there will be a number right here at the vertex. Yeah, a lot of times they make it red. Sometimes it's black. Notice what it's missing. It's missing a degree symbol, right? When it's missing a degree symbol, it's not saying that this angle is 1 degree. It's saying that this is angle, right? That's a 3rd or 4th way of naming it. The two yellows are technically one way of naming it. So really that's three ways, although there's four examples right here. Okay? So those are the four, really three, ways of naming an angle. We can only use this angle B when it's by itself. It's by itself, so we call it angle B. So guess what I want you to do in box 2? Name that angle. So go to box 2, name that angle. There's 4 lines here. Suspiciously, there must be 4 answers. Name that angle.
Oh, wait. I see.
Yes, every time you got to put the angle symbol. Yes. All right, Hannah, give me one way of naming this angle.
Angle DEF.
Angle DEF. Aiden, give me another way. Okay, so there's those two. Lucia, give me another name. Angle E. Now, the only reason we can call this angle E is because it's floating by itself. You got the last one, Abby? And if you didn't hear what Kai asked me, he says, do I have to put this angle symbol for all these answers? Yes. That's what's telling me it's an angle. If there's one letter there, that can mean it's a point. But with an angle symbol, then oh, wait, it's not point E, it's angle E. Okay? Cool? That might be new for some of you. I did teach you this last year, but that might be new for some of you. Jaden, put it down. Okay. Box 1B, write this down. Definition 1B. Vertex. Vertex. That's it's that point right there. This area right here. It's where the two rays intersect, right? Or the two sides of the angle come together. We call that the vertex. Now, interestingly enough, the vertex is, it is a point. It's point B. The vertex is how we measure angles with a protractor. The hole on your protractor must go on the vertex to measure an angle, which will be the next thing that we do. Like I said, this isn't, you're not going to pull out a protractor in your book, but I always include this in the instruction. Okay, everybody got that definition down? No. The plural of vertex is vertices. When we start talking about shapes here in another day or two, a square has 4 angles, therefore it has 4 vertices. Okay, protractor. Everybody look at your protractor. First and foremost, the hole must go on the vertex. Protractors are challenging because there's 2 scales on them. You see the 2 scales on your protractor, right? They both start at 0 and go to 180, but one starts on the left as 0 and goes to 180 to the right, and one starts on the right as 0 and goes to 180 to the left. That clear as mud, right? So the question is which one you use. Now everyone look at me. Okay, my hands are the 2 rays. Big or little angle? Big or little angle? When you, and you're already using the right words, but when we look at a little angle, right? If you measure a little angle and it measures to right here, here is your angle, it's either 220 or 160. All right, let's use some common sense. Is that a big or a little angle? It's a little angle, so could it be 160 degrees? It must be the other scale, because think about it. When the 2 rays come together, that's 0 degrees. When it starts to open up, that's when it gets bigger and bigger and bigger and bigger. So you're not going to start at 180, because look, the numbers are counting down. You're going to start at 0. But if I take that same angle, this one, and I flip it over this way, once again, you might be measuring this angle right here. Well, it's either 160 or 20. The process starts by looking at the angle and asking yourself, is it a little or is it a big angle? If it's a big angle, you're going to read the big numbers. By big, I mean like, in the hundreds. It's a little angle, double-digit number, you're going to read the double-digit number. Does that make sense? The number one mistake kids will make when they're measuring a protractor is they will read the wrong scale. All right, I will now show you how to use your protractor. So there is an angle. Here's my protractor, right? I don't have a hole, but I got a little notch, right? Imagine that is the hole. I take that notch, that hole, and I put it right there on the vertex. You see it? Okay. Secondly, I look at this angle. Is that a little angle or is that a big angle?
It's
Everybody see it's a little
It's a
angle?
long
And I mean
angle.
degree measurements. So when I read the scale, it's going to be the small number. So you got to line up your protractor though correctly. The hole goes on the vertex. The 0 line on your protractor, you got 2 zeros, this one and this one. Your 0 lines line up with this bottom ray. And you got to really line them up. So I put the notch right there, and I line up. You see what I'm touching, the 0? You line that up, both things now. And if you can see precisely, I've got the hole on the vertex, and I got the 0. See the shadow of the line is on the 0. You already told me this was what, a big or a small angle? You said it's a small angle. Because if I read this, it says 155. That's pretty big. But remember, there's another scale for the small angles. It says it's between 20 and 30. It's closer. I mean, the halfway part would be 25. I'm saying that's about 24 degrees. See what I did? That's what you guys are about to do. In box number 3, there are 4 angles. Now, before you measure one, I got to show you one other thing. You see that angle? Big or small? When I line this one up, I got a problem. Notice this doesn't go up to where the numbers are. So guess what you got to do? I take the straight portion of my protractor, I line it up like this with that ray, and I do what? Where's my clicker? I draw another line. I extend the line. See what I did? I extend the line. Now, when I line this up, line my 0 up, I know you already told me that was what, big or small angle? So it can't be 35 degrees. I mean, it's pointing to 35 degrees. I must read the other scale. It's between 140 and 150. That's 144. Okay? Got it? Has anyone never measured with a protractor before? You had me last year, right? Okay, especially for you new kids, I'll walk around and give you some hints. All right, everybody else, some of these you might want to lengthen both rays in order to use it. Some of you may only want to measure one thing, but all of you, right, must now measure your angles. You know what you're doing?
Yeah.
Okay. New kids, you know what you're doing? Got a chance? Okay, I'll help you do one. All you need to do is see it done right once. Okay, so big angle or small angle? That's big. So when we place this here, this is going to go on the vertex. I would actually extend this one. Extend that one too. It just makes it easier. Okay, now line everything up. Yeah, and you see this line right here? Yeah, there you go. Perfect. Now, you already told me it's a big angle. So I look right here, it says it's 40, 50, it looks like 46 degrees. So you know it's a big angle, so we better read the other stuff. It's good, what 2 numbers?
Oh, he starts screaming at you.
So, and that middle mark would be 135, so it looks like it's 130. Now I'd go 133, 134. Okay, do the rest. Yeah, is it a big or a small angle? It's a small angle, so I would say 2 or 3, one of those. You need to be within 1 degree, plus or minus. If you're like 5 degrees off, then you're not being accurate. Also, when you extend your lines, don't do it by hand. Like if you try to extend it with just your pencil without using a straight edge, inevitably it's going to curve a little bit. If you're, I don't know, if you're only about 10 or less degrees off, right? It's just, you just really weren't accurate in reading. If you're lots of degrees off, you're doing something wrong. So when I show you the answers here, I mean, if you're 1 or 2 off, right, you're probably good. If you're 5 to 10 off, you just weren't accurate. You didn't line things up precisely. But if you're 30 or 40 off, make sure you raise your hand so we can help you. That's fine. They're the same angles. Yeah, sure. I don't know if I got that number, but I got one that's close to it. Yeah. No, you got to measure all the angles.
Yeah, I did.
Hey, Mr. Chartier,
Yes.
I don't have a protractor.
Sorry.
I'll run to your house to give you one.
All right. Here we go. Gabby,
Okay.
up first, what did you get? She got 51. You guys got
52.
51, 52. I measured from somebody who was 53. I'm not saying I've got absolutely the correct answer, but I got 52. All right. So if you're within 1 degree, which by the way, 51 and 53 are, we're in agreement. If you got like 55 or 50, I'm just saying you just want precise. Did anybody get something crazy?
80.
I got 30 degrees or something like that. That's really way off. You need some help.
I got 100. That's the other thing I'm-
Bottom left, Jaden, what you get? 25.
28.
30.
30 is really different than 25.
28.
I got a 20.
Okay, I got 28.
How many-
I'm going to claim that Jaden's answer was too far away from 28. Jaden, measure it again and try to be more precise.
Does 30 work though?
30 what?
30 work. Does it work?
30 is within 2, right?
Okay.
I'm not claiming that I got the right. I mean, the answer might be, I don't think it's 30, but it could be 29.
Yeah, I got 40.
I don't think it's 30, though.
Could
Oh,
be
yeah, you're right, it is
28.5.
All right. What do you got, Jenna? The upper one? What'd you get? Speak. Well, just tell me what you got.
She got 50.
Hey, Jenna, is that a big or a small angle? Okay. So when you read the wrong scale, that's why it's got to be part of the process. Bigger. Abby, what'd you get? 133?
147.
133.
147 is way off.
134.
I got 135.
I got 133.
I got 131.
Measure it again.
I got it.
All right. 142 is way off.
Yeah, you're right. It's not.
And you see also that you're not lined up down here.
I got
Now we'll read it. We get 134.
Hey.
I got 133.
All right.
Got 130.
I'm not claiming that's the answer, but it's darn sure close to that. All right. Last one.
92.
90.
Some people, when they measure this, they get 90. I tried to make it not 90. I tried to make it 91 when I drew it. I'll just say you got 9. That's fine. Okay.
I didn't even measure.
Are we good on protractors?
Yeah.
Okay. Just so you know, tonight for homework, it's going to ask you the measurement of angles. Are you listening? Should you use a protractor tonight?
No.
No. None of the math tonight is asking you to use a protractor. I'll show you what it's asking you to do. All right. So here comes the meat and potatoes of the entire class. Here we go. The first hard thing of geometry is this right here. There are 2 things. The last class we got segments. Remember, there's 2 ways of talking about segments. It's name and it's measurement. Remember, in segments, if we're talking about its name, it gets a symbol, a segment symbol over the top. If we talk about its measurement, you erase that part. The same thing for angles. We have a name and we have a measurement way of writing the answer. The name you just did in box 2. What's the name of this angle?
B.
Angle symbol B, right? You don't have to say the word angle symbol. When we talk about how big it is, you got to pay attention. This is new. Tonight for homework, they're going to have this and they're going to have this. When you see this, they are asking you to measure it, not with a protractor, but with logic. No protractors tonight. So the measurement will have an M attached to it. And the M stands for literally the measurement. So this means the measure of angle B. Well, if the only thing there is a picture like this, I got to use a protractor, but that won't be tonight. You're going to have some numbers to mess around with. I'll show you as we go in class. So when you see this tonight, they're not saying, look at the thing. That's what they're asking you to do there. Look at that thing. Hey, angle B. When you see this, they're saying, well, how big is it? They expect an answer. The answer will include 2 things. It will include an equal sign and a degree symbol. Yes, that doesn't mean 0, that means degrees. Yes? Yeah. Okay. Classifying angles, you should know this. This is a review. There are 4 angles. Okay, there's more, but we're going to talk about 4. The smallest angle is called a, what makes it acute?
It's smaller than 90.
But greater than?
0.
Write that down, please. All right, an acute angle is smaller than 90, bigger than, how would we write that mathematically? Smaller than 90, but bigger than 0. What?
Less than. Oh, wait,
So you do a greater than symbol. I just think about the 0. You put a question mark or an X, and then you put 90 with another.
Everything is right except the greater than symbols. We actually want less than symbol. We want that symbol because what is in the middle is the measure of this angle, angle C. So we're saying angle C is bigger than 0, but smaller than 90. Right. No, you're thinking of triangles.
Jackson, you tried.
But that is correct for triangles. All right, what's the next angle?
It's not.
Obtuse.
No,
Oh,
Right
that's a triangle too.
right angle. Next one, box 4B. If you are a right angle, you are exactly. So I don't want to use less than greater than, I want to use an equal symbol. So the measure of angle C is equal to 90 degrees. What the heck is that box?
It's showing that's a 90 degree.
If you see that little box, squares have right angles. You see that little box, it's telling you the angle measurement is 90. It is the only symbol we have for showing a specific angle measurement. We don't have one for acute. We don't have one for the next one either. We good?
Yep.
Is this new to anyone?
No.
Good. The next one is,
Obtuse.
so how are we going to write that?
Bigger than
Less-
90,
no,
smaller
less
than.
no, greater than 90,
Less than
smaller than
180.
180.
Correct. So if you are obtuse, you are bigger than 90 degrees, smaller than 180. You're obtuse.
What was the last?
There's one more.
Oh, is the right or the one that
You
goes
just had it right.
straight?
What is it?
Straight.
All right, the last one. We good on this?
Oh my
The
God.
last one is, if it's, there are more, but the last one is it a straight angle, right? And that means it's equal to 180 degrees. Like, well, I don't even see an angle there. Right, because the two rays have now formed a line. You go from any 2 points on a line, it's 180 degrees. If that makes sense. You go completely in a circle, 360. Not yet. We're not even to the new stuff yet. All right, we good on the 4 types of angles.
No.
Yes.
Okay. So guess what I want you to do in box 5?
Oh, if you want.
Just name them. Go. 10 seconds.
But there is no straight
Well, I didn't say there was going to be one.
one. Then it's just
Just name them. And it's not Fred, Joe, Nancy, Bob. All right, Jackie, give me all 4 names. Upper left is, lower left is, upper right is, and depends upon what your measurement was. For some of you, this is,
90.
for some of you, it's,
Obtuse.
some of you, it might be acute. If you got 89 degrees, then you got an acute angle. If you got 92 or 91 like I did, mine's obtuse. And if you got exactly 90, then you got a right angle. So I'm going to call, since most of you said it was right, it could be any one of the 3.
Oh, yeah.
Okay, we good? All right. Now comes the new stuff. All right, here we go. Okay, when you have 2 angles and you push them together, right? And you push them together.
Whoa, you clicked it. I just watched it.
Yes. Oh,
What you're putting
what are we going to call this angle and what are we going to call this angle?
A, C, D.
Well, I already got that part. Okay, hang down for a second. Okay, I'm going to show you this again. If I take 2 angles and I push them together, show that they share a common side, what are we going to call this angle and this angle? Somebody already said it back there. We are going to call those 2, because they're next to each other, we're going to call them adjacent. Notice this time they won't share a common side. Watch. Now they overlap each other. In fact, they formed a whole bunch of new angles now. These are not adjacent. Look at this picture. Okay, when they overlap each other, we don't call them adjacent. We call them adjacent when they share a common side. Write this down, please, box 6. These are called, the green angle and the blue angle are called adjacent angles. Why? They both have C as their vertex. We got angle ACD and BCD. They share a vertex and a side, but there's no points in the angle that are contained within both angles.
There are 3 angles.
There are 3 angles, correct. The large one and the two medium ones. Okay? There's actually more because we have what's called the reflex angle, which is this one. And then you got from here to here. And you got from here to here. So there's lots of them. But that general description right there, 2 angles next to each other, that means they share C, right? And they share that common side. Okay? Those are adjacent. Tonight for homework, it's gonna ask you to identify adjacent angles. They're gonna give you a shape. It may or may not look like this. And they're gonna ask you to name the adjacent angles. That means angles that are next to each other. There can be no space between them. They have to be next. That means they have to share a common side. Notice, both of these have the letters C and D in the angles. Yeah. Go ahead.
Another one,
ACB would be the whole darn thing put together. Okay. But ACB isn't adjacent to any angle in this picture. Okay. All right. So this is kind of like for homework. They're going to ask you to box 7. They're going to ask you to name the adjacent angles. Priscilla, what are the 2 adjacent angles? And you could say it any way. She said that very good. FEG, I call it HEG, but you could call it GEH either as well. Notice the issue of naming an angle E. Angle E doesn't describe any one of the 3 angles, right? You're like, well, which one do you mean? You mean the 2 small ones or the big large one? So those are the 2 adjacent angles. We okay? Tonight for homework, we're going to ask you to do this. That's what adjacent means. New stuff. We good? Okay, that wasn't too bad. All right, next new set of angles. What's that shape?
That is
It's no.
intersecting.
That are 2 lines intersect. I guess if we were to call it non-geometric, we'd call it an
congruent and
we would call it an X. Do you see the X?
no.
When you make an X, how many angles do you make? At least 4, right? You see the angles 1, 2, 3, 4. 1, 2. Sometimes I wonder why I choose things for animation. That was too slow. All right, you see the 4? There are more, but those are the 4 I want to point out. All right, I didn't get to name this. I would call it a different name. What do you call the 2 angles that are above and below or left and right of each other?
Congruent angles.
It would be nice if we called those opposite angles, right? Because they're opposite each other. These are the angles that are opposite of each other when you have this X. Okay? Except the math gods decided not to call them opposite angles. They called them vertical angles. So on your paper in box 8, step 1, draw that X. Label the angles 1, 2, 3, 4. You don't need to do the coloring.
Wait, but the number 9 is already there.
Do it. Okay. Now, if you want to know why they call them vertical angles, because this thing can be shifted. I could take this thing, rotate it 90 degrees, then the red would be top and bottom, then they're vertical at each other. But yeah, you can kind of think about it now. It's inappropriate math language to say they're opposite. Opposite means something else. But in general, everyday speak, think of this as the angles that are opposite each other. If we were to take a protractor and we were to measure the 2 blue angles and then measure the 2 red angles, guess what we would find? They're the same. Now, we're not saying that blue is equal to red, but we're saying that the 2 blue angles, if you measure with your protractor, you can do it if you want to, you're going to find out that they are the same. Therefore, what can we say about all vertical angles? If you have two vertical angles, they are, we say the word congruent. We don't say the word equal. We say their measurements are equal, but we say that they are congruent. Box 9. Write this down. Large, bold letters. Vertical angles are congruent. I'm not saying that all vertical angles are equal to each other, but what I'm saying is that if you have two vertical angles, I do, that 1 is congruent to 3, that 2 is congruent to 4, because they are vertical of each other. 1 and 3 are vertical angles. That means that 1 is congruent to 3. If we want to talk about their measurements, how would we write that?
Like which, like.
We want to talk about their measurements, how would we write that? Measurements are never congruent. How do we write that? That's how we write that. Once again, this is the name, this is the measurement. So we're saying that angle 1 is the same as angle 3. That's what congruency means. If you want to talk about actual numbers, I don't know what the numbers are. 1 is clearly obtuse, maybe it's 150 degrees. But 150 degrees would be equal to 150 degrees. We can say the same thing about angles 4 and 2. Angle 4 is congruent to angle 2. That's the name. We want to talk about its actual measurement, right? 2 and 4 look like they're acute. We would say that angle 4 is equal to the measurement of angle 2. No, we're not done. Who's lost? Not a hard concept, but it's brand new. Vertical angles are congruent. Vertical angles are formed when you see a what? When we see an X. When you see an X, you look at the angles that are opposite of each other. Technically, they're vertical. Then we say that these two angles are congruent, their measurements are equal. And these two angles are congruent, their measurements are equal. We good? All right. This is what the homework will look like tonight. They will give you, what's the shape? They will give you an X. Brecton, if this one is 65, how big is this one? If this one is 115, this one is, can you do that?
Yeah.
You couldn't do it until I taught it to you, but yes, that's what they're going to have you do. They can make this more complicated, though. We good on vertical angles? All right. Go ahead, do box 10. Do box 10. Look at what you're given. Olivia, how big is angle 7? I hear what you said? 145. Okay. Yes? Caden, how big is angle 8? Let's see, angle 8 is opposite angle. Okay. Angle 8 is opposite of 6. And how big is 6? I'm not at, no protractors. Look at what you're given. It's on your paper, buddy. So therefore, angle 8 is, because they're vertical. They're opposite each other. Did you hear what I said? I saw him messing with his protractor. No protractors tonight for homework. You're going to get the measurements because of what you know about vertical angles. All right. So now they're not going to ask you measurements. They're going to ask you names. Grayson, name an angle that is adjacent to angle DBE. You take your finger or a marker and you trace out angle DBE so you know what you're talking about. So follow the letters, D to B to E. So I'm talking about this angle. Give me an angle that's adjacent to it. He said ABC. Is that one next to it? Nope. ABC is not next to it. DBA shares point B and side DB. That one is adjacent. Also, EBC, because it shares point B and it shares side EB. So these two angles are adjacent to angle DBE. So those two angles are adjacent, Abby?
So does it have to be?
Yep. You heard your question? Because remember, angles could be either EBC or CBE. Okay. All right, Grayson, give me something vertical to this angle EBC. Give me something that's vertical to EBC, and he said DBA. Are there any other angles that are vertical to that angle? No, there's only one answer for that. I said ABD, he said DBA, same thing. Yes?
Yeah.
That's what homework will look like. One last thing. If you take the angle, in this case angle, okay, and I cut it in half through the middle, right? So that angle E was 40, now I made two angles that are, what are we going to call that red ray right there? You take an angle and you cut it in half, what are you going to call that red ray right there? What would be a good name for it? What did it do?
Just the 1/2.
So we could call it a cut in half angle, right? Or cut in half ray. Do you think that's what the geometry gods called it?
Nope.
So there's a more fancier name, but that's what it did. It's the cut in half ray. Anybody can think of a better name?
1/2 E.
Okay. It is called, write this down,
I knew that.
last box. It is called an angle bisector. An angle bisector, by two. I cut it into two equal sectors. An angle bisector is the red part, is the ray that cuts a given angle into two equal parts. Tonight for homework, it's going to talk about an angle bisector. Okay? Going to talk about an angle bisector. Mathematically, what does bisection do? Mathematically. Mathematically, numbers-wise. What does bisecting do?
Cut it in half.
Mathematically, what does that mean?
One half it.
You
Divide by half.
divide it by 2.
Oh.
Remember, dividing by a half actually means what? When you divide something by a half, copy, dot, flip, dividing by a half actually does what? It doubles it, right? Dividing things by 2 is what angle bisectors do. Angle bisectors take a given angle and cut it in half. All right, last thing. Stop what you're doing, watch the board. For the curious, right? If you are given an angle, any angle, you're given an angle, and you are asked, we'll call this angle B, and you're asked to make this angle without a protractor, what do?
Freehand.
This is how we make angles. Here's how it's done. This is kind of magical. Here's what you do. Step number 1. Take the pointy part, put it on the vertex. Draw that.
Easy.
Okay? Don't change this. Take a straight edge, not a ruler. Draw a line. Call this C. Take the pointy part, put it on C, draw that arc.
Easy.
Now I need you to measure from here to here. So I'm going to measure from there to there, right? See what I did? Take this, put it right there, measure. Take your straight edge, connect the dots, and I have now made
An angle.
a congruent angle. These two angles are exactly the same. You will do this in high school.
Oh.
But for the curious, that is what the straight edge, not the ruler, the compass, I'm sorry, protractor, and the compass are all about.
If they have to use my compass, it's like my protractor,
Protractor protractors are used to, because it's got that straight edge, to make straight lines. Your compass is used to actually make things. Yeah, that is true. Well, it's hard to make a circle out because you're missing one. Well, notice it doesn't go completely around.
Right.
It
So you go like
stops.
this, and then you stop, you put it back on the line, and then you go.
Try making one, you'll find out it doesn't make a
Where's the
circle.
water?
All right, maybe your protractor trying to make it out.
You put it in the girls' bathroom.
I'll have to go check.
I wonder who took it.
Hello?
Bye-bye.
Bye, Darvin.
See you later, bud.
Bye, Darvin.
Don't forget
Bye.
about your dangle stick.
Bye.
You're a dangle stick.
I know you are.
All right, Donna, any questions?
No, thank you. Wait,
That'll
I
do.
do have one.
Yeah.
When we get to the measuring, how do I measure when I don't have a protractor?
There is no protractor necessary for tonight. They're either going to
I
give
know,
you either
when we
vertical or
I know, I'm talking about in the future when we start measuring.
we're not going to measure anything this year.
Oh, okay.
All right,
Okay.
catch you later.
Bye.
See ya.
Do I have to be here?